All right, guys. So I'm just going to quickly recap what we have gone through just now, just for clarification for those who didn't clearly get it. And hopefully at the end of this recap, we can all be on the same page. All right. So our aim here is to find the product of binomial expressions. So we are finding the product of two binomials. And we say that a binomial is an expression with two terms. It consists of two terms. And clearly, each of these are an example of a binomial. But if we are finding the products, that means we would bracket them. So each binomial, we bracket them so that we can treat them as a single term. So you have this times this bracket. Now, just like terms, when you group brackets together, there's an individual multiplication sign between them. So once you see them like this, it means that you're multiplying them together. So you're finding the product. Now, this diagram is to illustrate how you would find the product if you were finding the area of the big rectangle. So we look at the length of the rectangle based on the length of A plus the length of B. So the length of this rectangle would be A plus B. The width would be C plus D. Now, if we multiply them, that would be the A plus B bracket with C plus B D bracket. Now, what that will do is that when you multiply them out, you would get this situation. So A plus B times C plus D, to multiply them out, you would have to apply the distributive law. Remember, when you're using the distributive law, you take what is outside the bracket, multiply what is inside the bracket. But in this case, we're taking, instead of, we're using the terms in the first bracket as what is outside the bracket. So each of these terms, we're going to use them once with the second bracket, applying the distributive law. So we're taking the A and we're using it to multiply the second bracket. So treating it as though the A was a single term outside the bracket, we would have A times C plus A times D. All right, so A times C simply give you AC. A times D will give you AD. Now, after we are through with using the A using it to distribute to the second bracket, now we need to use the B and do the same thing. So we're going to treat now the B as a single term, using it to multiply out the second bracket. So we have B times C, we get BC, and then B times D give us BD. So when we remove the brackets, then the result that we obtain from doing the multiplication would be this four-term expression. So when you multiply these two binomials, you will get AC plus AD plus BC plus BD. And so this would be the product of removing the bracket or multiplying out the two binomials. Is that clear now to everyone? Let me see your hands if it is clear to you. All right, so that's what we're doing. So if you're asked to remove the bracket where you have binomial, it is the same procedure that I've just showed you that we will use to remove the brackets. Now, I had mentioned that there are more than one ways to do it. So I'm going to show you also another technique shortly after. All right, so without the use of the diagram, and if we go back to the diagram, you will notice that when we multiply the product, what we get as AC plus AD plus BC plus BD would actually be these little areas in the bigger rectangle. So AC plus AD, BC plus BD. So all this is saying when you multiply two binomials in terms of a geometric shape as a rectangle, you can cut up that rectangle into the smaller rectangles, and by multiplying out, you will get these little rectangles. You multiply them. If you multiply them length by width, you're finding the area of each of these. So if you add up each of these in terms of their area, you will get the area of the bigger rectangle. So that's all that is saying from a geometric point of view. So we are saying that these are the lengths of the bigger rectangle, the A plus B and the C plus D. These are the length and width of the bigger rectangle. And these are the length and width of the smaller rectangles. So when you add up all of these smaller rectangles, their areas, you would get the same area as the bigger rectangle, which is A plus B times C plus D. All right. So we say now, without the use of the diagram, we could expand the brackets by using one of the techniques that follows. So we just look at how to use this one. So this one is a distributive property that we applied. But all we did first, we use the first term in the first bracket. We use that term distributed for the second bracket. And then we'll get AC plus AD. Then we use the second term, distribute the second bracket again. Then we get BC plus BD. All right. Now the other technique is still using the distributive property. But instead of doing it as before, what we did now was to take out the terms from the first bracket. So the A that was in the first bracket, we take it and we write the second bracket because we're using the same distributive law. So we take the A and distribute the second bracket, which is C plus D. And then we plus the B, and then we distribute the second bracket again, which is C plus D. Now, it is pretty much the same as what we were doing. We just split them up with two different brackets, two different scenarios. So the first term with the second bracket plus the second term with the second bracket. So it's still distributing the first term in the first bracket with the second bracket. So we'd have AC plus AD plus BC plus BD. And so you see, we still have the same result. We would have arrived at the same result. So this is just an alternative way of how to carry out the expansion. So from here, let's say you didn't want to use this technique. What you would do, you would take the first term, and then now you write it in front, the second brackets. And then you put a plus sign, take the second term, write it beside the second bracket again. And then what you would get from that is what we have in the second scenario, which is this, right? So you would get this as a result. And by distributing each of the brackets using A and B, then we'll get this result, which give you the exact same result as before. Now, this is a third way of distributing the brackets. So we kind of write it in this fashion to kind of mimic what we used to in terms of multiplying numbers, but it still applies distributively. Because what we're going to do is take the A. So we're multiplying by the C plus D, we're multiplying by the A plus B. So we take the A and multiply A times C plus A times D. So we'll get what? AC plus AD. Then after we're through with the A, we take the B, and we take B times C, then B times D. So that would pretty much give us AC plus AD, and then we would write it like this. So we have AC, when we use the A, we get AC plus AD, and then we write that. Then we use BC plus BD, and we write that. Now, when we're doing numbers, we generally shift our place value to the left. But when we're doing this, we shift it to the right. Now, you may not see the importance of lining up these two middle ones using these variables. But when we're doing quadratic, it will work the very same way as how we have it here. Now, those are the three techniques that I will give you for this purpose. Now, I'm not saying that you need to use all three techniques. All I'm saying that whichever one of the techniques that works best for you, you're just going to stick with that technique and use it. Is that clear, guys? Let me see your hands if you understand what I'm saying. All right. Now, the technique that is often used is the one that we were using first. Why people generally use that techniques more? Because it saves a lot of time in terms of working out. So it is a shorter one to use. But for some person, it might be a little confusing more than the second one. And so whichever one you feel comfortable with, you work with it. All right, so moving on now. When we add up all of these, we will get the same result, AC plus AD plus BC plus BD. Here now, we're going to look at some examples, probably about 2 examples. So here now, we have 2 binomials, and we want to remove the brackets. Now, just to see whether or not persons were actually following me, I'm going to call on someone to walk me through the process to see whether or not we would be able to carry out this process without me doing this example. Any volunteer? I just need one person to walk me through this. If you feel comfortable that you understand what we were doing, you can walk me through this process. Mr. Campbell, you think you'd be able to walk me through the process?
Oh no, sir. Let's try. We try.
All right, let us see what happens. So tell me what to do.
So.
And remember,
what?
Remember you just learned 3 different techniques. So which the first one, second one, or the third one?
The first one, sir, most definitely.
All right.
So we're gonna remove the brackets now. We're gonna say 3 times R. Well, I like to label them first. So the 3 in this case would be A, and 2 would be B, and X would be C, and D would be, and 4 would be D. So we're gonna multiply 3 times X, which would give us 3X squared.
All right. So what you're saying, you're taking the 3x times this.
Yes, sir.
All right. So 3x times x will give you
3x squared.
3x squared.
Yes, sir.
All right, next.
And then we're gonna add a plus sign,
All right, keep your plus sign.
and then next we're gonna say 3x multiplied by 4, which is 12x.
All right, so that give you 12x. All right.
Right. And now we're gonna move on, and we're gonna say 2 multiplied by x, which would give us 2x.
All right. So here we have 2x. All right, so this would be just to track what you were doing. So the first part we do 3x, then 3x times x give us x squared, then 3x times 4 give it 12.
12x.
We're using 2 times x, get what?
2x.
All right. So we have 2x.
And then we're going to multiply the 2 and the 4 now, which would give us 8.
All right. Sometimes I believe this thing has a mind of its own. Leaves a light on this thing not working so well. All right, so what we do next?
We're going to multiply the 2 and the 4, which would give us 8.
All right, so we get 2 times 4, give us 8. Now,
Yes.
notice here in this expansion, so we would get 4 term in the when we remove the bracket, we get 4 terms, right? But if you notice the 2 middle terms though, what can we say about the 2 middle terms?
They are like terms, sir.
They are like terms. And because they are like terms, we would like to just simplify them. So the 2 middle terms are like terms. And to simplify them, we're simply going to add them. So what would we get? For the
14x, sir. 12 plus 2, it's 14x.
14x. All right. And so instead of simplifying to 4 terms, we are simplifying now to 3 terms. All right, let me answer the question, guys. All right. Now, if we call a 2-term expression binomial, what would we call this 3-term expression? Go ahead, Mr. Lisa.
Trinomial, sir.
Binomial. What would we call an expression that has 4 terms?
Quadri something, sir.
Anybody else would like to try? So we know that if the expression has 2 terms, we call it a binomial expression. If the expression has 3 terms, we call them trinomial. But if you have 4 terms, what would we call them? Anybody? Go ahead, Miss Wilson. Miss Wilson, you want to say something? Your hand is up.
Sir, me never get it right.
No?
Quadrinomial.
Quadrinomial.
Oh, okay.
That's not correct. Anybody else would like to try though? You can lower your hand now, Miss Wilson. Miss Shea, what would you call it? Miss Green, what call it.
Sir,
Yes.
I don't know if I'm correct in about trigonometry.
Yeah.
Is it that?
No. No, we're not really referring to any geometric shape now, but what we're referring to would be expressions. And we're looking at expression based on the terms in them. So we name them.
Oh, sir, question.
Yes.
Would it be quadratic expression?
No. What
Okay.
refer to a certain type of trinomial expression.
Okay.
Right. So we have quadratic expression, but it is specific to a trinomial which has certain properties, which we'll look at later on. So nobody knows. All right, let me give you a hint. If we have a triangle, how many sides it have?
3.
Okay. Now we would have a four-sided figure. We would call the four-sided figure what?
Square or rectangle, sir?
Well, you have rhombus and you have trapezium. Those are also four-sided figures.
Okay.
But that's those are not the names that we are looking for. Now, suppose we have a geometric shape with many sides. What do we call it?
What, sir?
What do we call a many-sided geometric shape?
Polygon, sir.
A polygon. All right, so that's a hint. What do we call a four-side, an expression consists of four?
Tripolynomial, sir?
Four times? It would be polynomial. It's polynomial.
Okay. Okay, sir.
All right, so for the purpose of naming expression, when you have two terms, it's binomial. Three terms, it's trinomial. But four or more terms, we refer to them as polynomials. Is that clear? All right, guys. So let us look at another example of this. So here, when we multiply these out, we will get 3x squared plus 14x plus 8. All right, here's another one. All right, I'm going to give everybody a chance to just, within about 2 minutes, work this one out. And I'm going to call on someone to present or to walk me through their, walk me through the process to their results. Anybody finish it already? All right, so let me ask now, Ms. Shea. Ms. Shea, are you finished? Ms. Shea is not responding at all. Ms. Green, would you like to walk us through this? Ms. Green, I'm not.
No, sir. No,
Yeah,
sir.
go ahead.
No, sir.
You don't want to.
Sir, I said no.
You don't want to help me through this one. All right, let me call on Miss Bellani. Miss Bellani, Ms. Belani, are you there? Would you like to help us out here? Ms. Cox? Like to walk us through this?
Yes, sir.
Would you like to walk us through this? All
Sir, I will try.
right, go ahead.
All right, so sir, first, 2p times 3p would have given us 6p squared, and then negative 3
Give me a second.
times
Let me just write.
3p.
All right.
Continue, sir.
Yeah, continue.
Negative 3 times 3p would have given us 3 is 9. Negative 9p. No, sir, sorry. Negative 3. No, sir, sorry. 2 times negative 4 would have given us 8p. And then we'll do negative 3 now. So negative 3 times 3p would have given us 9p. And then negative 3 times negative 4 would have given us 12.
Yes, you said just 9p. Which sign you're using?
So negative.
Okay.
And
Until
then we'll have negative 3 times negative 3 times 3p would have given us 9p. Then negative 3 times negative 4 would have given us positive 12.
okay.
And then we would so negative 8p take away negative 6p.
Say that again.
So negative 8p take away negative 6p would have given us 2p.
All right. I'm not sure how you take away negative 8p from 6p because we really don't have any 6p there. We have 6p.
Sir, and 9. Sorry, sir, 9. Sorry.
All right. So what else? All right.
So, sir, you would then take away negative 8 from negative 9.
All right. All right. So I would rather you say that you're adding both of them negatively.
Yes, sir. Sorry.
All right. So
I was
when you add
confused with
them
that.
negatively, what you get?
Sir, negative 17.
Negative how much?
17.
So what,
Correct.
yeah, what should go in the middle?
Negative 17p
17p.
plus 12.
All right. Thanks much, Ms. Cox. Good. I must say, yeah, you got it correct. So thanks for your effort. All right. So let me see the hands of those who are now comfortable with what we're doing here. All right. So you're going to try these now. So I'm going to I'll just give you about 10 minutes to do all of these. And then now after you're through, I'm just going to ask individuals to walk me through each. So just be prepared to work one of these problems. All right, so I'll give you 10 minutes.